I'd like to welcome you all to Red Deer Public Library's Travel Memories program, the first of a new season. We're lucky to be doing it by Zoom because our guest is in Calgary, and this makes it a whole lot easier. This is also a special month in Alberta where we celebrate all sorts of activities. And we're in particular want to celebrate or hiking and we have a hiking fall challenge. We'd like you to all to come in and pick up the sheet and fill in the challenge. And because this particular program is particularly involved with Alberta, I'd like to open with a land acknowledgement. As part of our commitment to reconciliation, we acknowledge that we live, work, learn, and play on the traditional and current lands of Treaty 6 First Nations, the Cree, Dene, Blackfoot, Saulteaux, and Nakota Sioux, and Treaty 7 First Nations, the Blackfoot Confederacy, Kainai, Pilkani, and Siksika, as well as the Tsuut'ina Nation and the Stoney Nakoda First Nation, and of the Métis people of Region 3. We respect the histories, language, and cultures of First Nations, Métis, Inuit, and all First Peoples of Canada, whose presence continues to enrich our community. So welcome, Dale.
Hey, thank you.
So we were fortunate to hear that Dale had a new book out called The Scenic Geology of Alberta, which just fit with our theme so well. And fortunately, he was willing to join me for this Travel Memories program. I think I'll let Dale introduce himself and tell us all about what we've been missing in Alberta all this time.
Hey, thank you, Priscilla. Thank you to the Red Deer Public Library. It's an honor to give this talk today. A little bit about myself. I'm a geologist. About 7 years ago, I started writing books for the public, get people out touring and seeing Alberta. And because I'm a geologist, I wrote about the Scenic Geology of Alberta. The first book was about Banff, Jasper, and Yoho. And this book, as I say, is about the province. And so what we're going to do today is look at a lot of different locations across the province, trying to encourage you to go visit them. And I'll explain how they originated. I am a geologist. I've got a PhD in geology. My first 2 degrees, bachelor's and master's, were in geography. I worked for a large Canadian oil company until I retired. And then before that, I was a research scientist with the Geological Survey of Canada. So that's a little bit about my background. So let's take off and look at Alberta. I'm going to show you a bunch of pictures. Just scenic sites across the province. Get you out of your comfort zone if you don't travel. Maybe try and get you to leave Red Deer and go explore the province. We've still got a lot of time left this year before the snows fly. Here's Dunvegan Crossing in Peace River. And so the way we've set up the talk, or the way I've set up the talk, is the Scenic Geology of Alberta is a story of unbridled power. It's a story of drama, a story of glaciers and volcanoes long past, and a story of when banks fail. As you go across the province, look at some of the sites. Here's Sulfur Gates Provincial Recreation Area. Just beautiful spot near Grand Cache. Pine Ridge Lookout at Waterton Lakes National Park, and you can see the Rocky Mountains off in the distance, and then the Rocky Mountain foothills in the foreground. Chief Mountain Police Post as seen from Police Outpost Provincial Park. Most people don't even know that Police Outpost Provincial Park exists. Given that this is part of the hiking fall challenge, there's all sorts of places to hike around Alberta. And a lot of these places I'm talking about have got rough trails and very well-developed trails. Riding on Stone Provincial Park, Ice and Ipey National Historic Site. Just a beautiful part of southern Alberta. Dinosaurs Provincial Park, everybody knows about it. Not everybody's necessarily been there though. Spectacular, and the dinosaur story is amazing. Here's Milk River Canyon. And Milk River Canyon, in my mind, could be one of the prettiest, nicest localities we've got in Alberta. It could rival, in my mind, sometimes the Icefields Parkway between Lake Louise and Jasper. Aretha Van Herk, the author, she wrote a blurb for the book, and she said, "Visible Alberta is stunningly beautiful, but the poetry of geology is its secret language, a transcendent stratigraphy." And all stratigraphy means is layers, layers of the rocks. And that's what you can see there. Layers of the rock in Milk River Canyon. If you go to Dry Island, Buffalo Jump, you can see the layers in the rocks. You can see the stratigraphy and the beautiful subtle pastel colors interrupted by coal seams. Go to Red Rock Cooley, and some people refer to this as a moonscape, and we'll visit it again. East of Red Deer, Mud Buttes. There are these features that look like they belong in the Rocky Mountains, but they've been created. They've been formed by glaciers thrusting bedrock east of Red Deer, where one wouldn't normally expect features like that. Elk Island National Park. There's a story there, and it's to do with the glaciers. A rotting block of ice gave you this topography. That's what we talk about in the book, Scenic Geology of Alberta, and it is a roadside touring and hiking guide. And I take people all across the province, from southern Alberta, central Alberta, and up into the north to look at various sites. In the book, I was lucky enough to be able to work with two artists. Brent Laycock put 8 of his acrylics, his landscape acrylics, into the book. Here is one, Dungarvan Ranch, from Waterton Lakes National Park down in the southwest. The other author, Lucy Carew, L.C. Carew, put the watercolors. She put 8 watercolors into the book. And there's a reason for that. With that, and the reason I wanted to do it is so that you, the people that get the book, the people that go exploring, they could look at the landscape of Alberta through the eyes of an artist, these 2 artists that contributed to the book, as well as through the eyes of a geologist, a scientist, such as myself. So it's worked out really, really well. So put on your hiking boots, fill your car with gas. It's time to explore and learn how Alberta's most scenic sites were created. Again, part of the theme with the public library right now in Red Deer, Hiking Fall Challenge. Hike and bike wherever you can. So we'll start with the Scenic Geology of Alberta is about unbridled power. We'll go to Waterton Lakes National Park to start there. And here's a scene, here's the scenery from Pine Ridge Viewpoint. Just as you enter the park from the north, what you see is this wall of rocks, this wall of mountains there. And then in front of it is the Rocky Mountain foothills. Well, why are they there? Why are those mountains there? Why do they look the way they do? If you go back 1.5 billion years ago, this is what North America would have looked like. And Waterton Lakes National Park would have been located probably south of the equator at the time. It was hot and harsh. It was a pretty extreme environment. So 1.5 billion, that's with a B, years ago, this is what Waterton would have looked like. And in the waters there, the marine waters, the basins, the oceans, the only thing that lived were algae. And those algae lived in colonies, and they would create these features called stromatolites. And they are like Brussels sprouts or small cabbages. If you cut them in half, you can see where algae would have lived on a surface like this. And they would have accumulated and just kept on accumulating and growing vertically up to give us many of the cliffs that you have in Waterton Lakes National Park. There's another version of them. Same thing, these dome-shaped cabbage or Brussels sprout features. So what are they? Well, here on the left is another stromatolite from Waterton Lakes National Park. Here is an example from the west coast of Australia, a place called Shark Bay. During the time that the rocks were being deposited in Waterton, nothing else lived on Earth other than algae. There was nothing on land, no plants, no animals. There may have been a little bit of bacteria floating around, but it was algae. Algae is what dominated the oceans in those days. Algae ruled the world. And I could have put a photo of a cliff, a photo of Cameron Falls, but instead I put Brent Laycock's Morning Sun on Cameron Falls. If you go walking and exploring in the cliff there, and it's right in the village of Waterton, you can find those stromatolites that we're looking at in the cliffs there. Also, if you, they built up in such accumulations or such great volumes that they form many of the cliffs and cliff faces that we see within the park. So unbridled power, that's what we're talking about here. So let's talk about that. We've set the stage for Waterton. Let's talk about why I say Alberta's scenery is all about unbridled power. Well, here is a Google Earth image of southern Alberta, northern Montana. There is Waterton Lakes area. There are these mountains in through here, and they have a shape like that. This is a separate isolated mountain range. It ranges from the distance from north to south is about 140 kilometers. It's about 40 kilometers wide. These rocks that we see at Waterton, they're about 7 kilometers thick. And the thing here is they were buried 10 kilometers or more deep. So when they were deeply buried, mountain building processes would have taken that block of rocks and it would have moved them to where they are now. Mountain building pushed that mass of rocks that we see at Waterton 140 kilometers to the northeast. Like that. So that took place probably 165 to 60 million years ago. That's when our mountains were built. The rocks at the time were deeply buried. And then for the last 60 million years, there's been erosion taking place to give you the beautiful scenery that you see in Waterton today. And that's what you've got there. If you want to remember anything from this little bit from Waterton Lakes National Park, remember that making up the cliffs, and in lots of these cliffs in the park are algae. It's dominated by algae. And that's from 1.5 billion years ago. And then the mountains were moved from 140 kilometers away to their position, their location where they are now. And then there's been 10 kilometers of erosion from the tops to give you those spectacular shapes that we see today. That is power. And that's why I say, consider the power, consider the forces involved in creating this landscape. Here's that Google Earth image again. And the next two slides are from here. It'll show you the scenery. Here is from the, I'll say the south side of the park, just before you get into the US. And there's the Waterton River viewpoint looking north. And you can see the ranges. You can see the mountains in Waterton. But think about how they got there. They were pushed from 140 kilometers away to take this position. You go around the corner, and what you see is the front of that mountain range that we saw in one of the first slides. There it is there with the beautiful foothills in front of it, creating these stunning landscapes that we've got there. Along the theme and continuing the theme of unbridled power, let's go to Sulfur Gates, and we're going to talk about a water gap. West of Edmonton, Hinton, north to Grand Cache is Sulfur Gates Provincial Recreation Area. Just a little foothills park east of Jasper, north of Hinton. And it's just a beautiful place to visit. And we have a water gap. And what a water gap is a narrow gorge cut where the river cuts through a resistant ridge. Here's a 20 to 30 meter thick, extremely resistant ridge, resistant to erosion, but it's been cut by the Smoky River. That's what makes this such an interesting area. You create a panorama, and what you see is the Smoky River flowing from the west to the east. It crosses that ridge of resistant cemented gravel that we call a conglomerate. The water gap is right there, right in the middle of that ridge. And then we have the Sulfur River, which flows into the Smoky, but the Sulfur is a small river. It doesn't have the power to erode across these ridges that are here. So it flows between the ridges. It's such an interesting little contrast looking at the power. There's another view of that. And I want you to think about the power that would have been required to erode this water gap, this gap within the cliffs in through here. When the Smoky floods, it's a very dangerous, very high water place. One of the artists, Lucy Carreau, Elsie Carreau, this is her picture, her rendition of Sulfur Gates, a watercolor that she did. And again, I think she's captured it quite nicely. We're still dealing with unbridled power. Let's go to Swan Hills, northern Alberta, northwest of Edmonton. And what you have are these highlands, these uplands in the area. And here's the Swan Hills uplands. And they're all capped with a large layer of gravel, boulder gravel, quartzites that come out of the Rocky Mountains. Some of them 20, almost 30 centimeters across. These were extremely large rivers which drained the Rocky Mountains. We don't know exactly when, but more than 2 million years ago to perhaps 50 million years ago. And these rivers were large braided rivers, much like the Athabasca River is in the Rocky Mountains. They carried these quartzites, and they carried the quartzites north and east, eventually making their way to Hudson Bay and the Labrador Sea, which is just an amazing story. And it's so interesting to go visit them on the top of the Swan Hills. These types of boulder gravels also occur in the Hand Hills near Drumheller. They form and they're preserved in Calgary. Or if you go to Cypress Hills, you see them capping the hills there. All an ancient river system, which was flowing eventually to the Hudson's Bay and then the Labrador Sea. More on unbridled power. Let's go to Edmonton. 1915, there was a flood, and it was to the base of the low-level bridge. So the river filled up to here. This is what it looked like at the time. The city of Edmonton was so worried that they were going to lose the low-level bridge. They asked the CNR to put a loaded freight train onto the bridge to help the bridge from being washed away. And here's a visualization of the river flooding up against the edge of the river. It was created by Louis Pereira from this image from the Edmonton Archives. And I just love the way he's done that. But that's the river when it's in flood. The opposite extreme also occurs. Here's Edmonton House, Hudson's Bay, Edmonton House. It's to make a point here. It's a reconstruction of Hudson's Bay, I'll call it their administrative building, from when the fur traders, the Hudson's Bay fur traders were active. And in 1796, Hudson's Bay journals tell us that the rivers were so low that the canoes were being damaged. They were having a hard time hauling furs and supplies. Furs could not be transported, there being no water in the river. Beaver and buffalo populations were down due to the dry weather. And in the records, they say that the fires burned all around Edmonton House on both sides of the river. So the other extreme of unbridled power is drought and dryness when the rivers were low. Let's leave that and continue unbridled power. And let's go to Red Rock Cooley Natural Area, south of Medicine Hat. So it's in the prairies, it's in the Badlands, and it's renowned for these giant boulders. And these boulders are called concretions. And they create this really spectacular moonscape type setting. So they occur in the gullies and in the coulees, and they seem to be concentrated with and associated with this light gray layer within these marine mudstones. And we'll talk about that in a minute. And when you look, you can see that these concretions, which are 1 to 3 meters across, sometimes welded together, and they can be up to 7 meters across. They form in this horizon, but then every time there's a big thunderstorm, a big rainstorm in the prairies, we get erosion of these gullies taking place. And as a result, these concretions start to work their way down slope, making their way eventually to the bottoms of the gullies and being concentrated there. Why are they there? Well, 75 million years ago, this area, southern Alberta, eastern Alberta, Edmonton, Red Deer, Calgary, was occupied by a shallow seaway, the Bearpaw Sea. And these concretions formed just below the seafloor in the muds. And they formed from rotting vegetation, they formed from rotting animals, sometimes a little bit of vegetation and shellfish. And that what happened is limestone started to precipitate below the seafloor around this dead, rotting organic matter to create these giant concretions. Then they got buried, came back up to the surface, and and you see them as they are now. In those concretions, you can see ripples from the ancient seafloor. You can see shellfish, bivalves. You can see fish debris, fish remains, fish bones. There's some of the material that rotted and contributed limestone to make these cemented sands and muds that you see. You can see, if you look really carefully, little circular patterns in here. This is how the concretions grew out, again, below the seafloor. About 12 kilometers, 15 kilometers away from Red Rock Cooley is a place called Bull's Head Butte. And at Bull's Head Butte, paleontologists have found a prognathodon, giant reptile. And he lived in the seas at the time. And that's why I put down that Red Rock Cooley as being unbridled power. Prognathodon was the top of the food chain. It ate what it wanted, when it was living in those shallow seas. So again, part of Alberta's landscape history. It was about 30 meters across, the length of a small school bus. Think about that. Swimming in the ocean and a marine predator. This is Lucy's rendition of Red Rock Cooley. And again, she's captured it very, very nicely. The Scenic Geology of Alberta is about drama. So for this one, we're going to go to Writing on Stone Provincial Park, Icenipe National Historic Site, right on the border. These are the Sweetgrass Hills, and they're in Montana. The border is more or less just at the bottom of the hills. And what you see are these beautiful hoodoos of sandstones that were an ancient shoreline. There is a large valley occupied by the Milk River. And this is an old glacial meltwater channel that the Milk River later occupied or reoccupied. The hoodoos, they're really spectacular to see. And what is a hoodoo? It's just a resistant layer of sand. It's cemented a little bit more firmly. And so when the winds blow, when the rains come down, this doesn't erode as much as the underlying sands. These erode, the lower sands erode more, and you're left with a cap rock, which is the hoodoo. Very, very mystical in shape, in nature. Writing on Stone, it's known for its rattlesnakes. So you watch for those when you're hiking around there. Here's a picture at Writing on Stone. You can see the Milk River flowing through there, and you can see the cliffs in the distance. And those cliffs, if you draw, we call it a section, what they look like, it tells the geology. At the base of the cliff, we've got marine mud rocks from an ancient ocean, from an ancient seaway. And then the cliffs are an old shoreline that was advancing from south to north. And then in the back, in through here, are old river deposits, coal and coals. So if you could go back in time 84 million years, this is what writing on stone would have looked like. There was a shoreline that occupied all of southern Alberta. And at that shoreline, a river flowed to the shore. Sand was deposited and swept along the shoreline. Writing on stone looks like the lower part. There's a shoreline, a barrier island, tidal deposits in through here. If you were there, you could have surfed on these waters. You could have swam in the lagoon. You could have paddleboarded in the lagoon. What I'm trying to do is give you a picture of what Writing on Stone Park looked like 84 million years ago. Here are the hoodoos again. So let's go on a little guided tour. So you'll take a path down to the cliff bottom, and you do it with a park's interpreter. And what you'll see are the pictographs, what the writings on stone. And one of them is called the battle scene. It's about 3 to 4 meters across, and so we can't do a proper picture of it to make a slide, put it on the screen. So this is a line drawing by one of the archaeologists who studied the area. And what you see in this battle scene and the interpretation of it by a Piikani elder called he was a Piikani elder called Bird Rattle. And it's to represent a battle scene called Retreats Up the Hill Battle that took place around 1866. What you see there is a camp of Blackfoot teepees. There's a defense line of muskets in through here. There are warriors of a combined group of the Gros Ventre, the Crow, and the Plains Cree who are advancing on this Blackfoot camp. So there was a big battle. There was about 300 warriors that were coming to attack the Blackfoot. The Blackfoot defended their camp successfully and defeated the advancing war party. And that's what this is to represent. We know that this is post-European contact. This is after the Spanish landed in North America. They brought horses and they brought guns. There's horses here. There's horses here. Guns, or warriors on both sides have guns. In this little photo inset here, you can see the guns drawn in black and white here, and you can see the muskets. They look like muskets and musket balls coming out. There's another battle scene in the cliffs at Writing on Stone Provincial Park. And this one is supposed to be much older, 1400 to 1600 Common Era, or AD, if you will. But that's the time, that's the age that they think it is. And the warriors at this time were on foot. You don't see any horses and you don't see any guns. Instead, you see the warriors carrying these big circular shields, and they're called pedestrian warriors. They would be carrying these shields on the prairie, and the shields would be made out of buffalo hide. On the left center are some probably dead warriors represented from after a battle. So we have two battle scenes, pre and post contact. No horses here, no guns here, rather spears and bow and arrows. Here's Lucy's rendition of Milk River at Writing on Stone Provincial Park. And again, she's captured it very, very nicely, including the cabins from the RCMP, the Northwest Mounted Police Force at the time. Let's continue the theme of drama. Cretaceous gold and the Lost Lemon Mine, murder and madness. Up and down the Rocky Mountain foothills are a series of ridges of cemented gravel. And there's a story about those, and that's what we'll talk about next. We're going to talk about this gravel, and it's called the McDougall-Seeger conglomerate. And these two pictures on your right and on your left are taken from the Frank Slide Interpretive Center on the Crow's Nest Pass. And you can see in a ridge above the parking lot some of that gravel. Well, the story about the Lost Lemon gold mine is that there were two trappers, Blackjack and Lemon. They discovered gold either in British Columbia or east of the Rocky Mountain Divide in Alberta. They discovered a lode, got a poke of gold, and they got into a fight one night. Lemon killed Blackjack. It seems like he instantly regretted it. He became unstable. He left the area. He wandered down to Montana, went into the Tobacco Plains area along the Tobacco River, and told his story. After that, a lot of colorful characters, Lafayette French, King Bearspaw, John McDougall, and a Blackfoot woman, Cloudwalker. They searched in vain, quite often with Lemon, coming to look for where his gold discovery was. It's said that there is a curse associated with those that look for the lost Lemon gold mine. Tragic deaths, fires, storms, and serious illness. Supposedly killed a lot of people. That's just normal day-to-day life in the 1800s. If you look at the legend, you will see names like Dutch Creek, Racehorse Creek, Highwood River, Gold Creek, and the Old Man River. Those are all rivers here's the Alberta-BC border, the gray line. And these are all rivers that drain the Rocky Mountain foothills from west to east. What this little diagram in the middle of your image shows are some ancient river channels, about 100 million years old, 90 to 110 million years old, and they drained the Rocky Mountains from west to east. And there's about 8 of them that have been identified from the Montana border in the south, north to just west of Calgary near Bragg Creek. So there are these rivers which are draining the Rocky Mountains. In the gravels, and the details don't really matter, except they tell us a little bit about where the gravels are coming from. There are volcanic pebbles. They were eroded from volcanic highlands, and there are igneous pebbles. And again, the names don't matter, but they're going to be important because they tell us that the rivers were draining this area in east central British Columbia. Plutons are where igneous rocks come from, those pink granites. But most importantly for our story, the yellow dots are all gold occurrences, gold mines, gold occurrences, placer mines that occur in east central British Columbia. So 100 million years ago, more or less, these rivers drained the area that is now the gold fields of British Columbia. If you go to an outcrop of a ridge of these gravels, and right below the ridge, if you pick up a bag of dirt, basically from the weathering cliffs that are there, put it into a bag, take it down to the nearest stream with your gold pan, and pan and get rid of all the lighter material, you'll quite often come up with gold grains. There's a scanning electron microscope of one of the gold grains from a pan like this, and sometimes you get platinum. There's not very much, but you might get 5 to 20 colors in the bottom of your pan. So it's quite an interesting little exercise, beautiful scenery, and great setting to do it in. Let's leave the gold mine, continue the drama. The geology of Alberta is about drama. Let's look at the origin of Okotoks, the Okotoks erratic, Big Rock, just outside the town of Okotoks, south of Calgary. This is the largest of thousands, if not hundreds of thousands of these types of boulders. These are really large, and there's an interesting story there. Where'd they come from? So one version of the story is that there was a giant landslide on Mount Edith Cavell. But before we do that, during the last glaciation, 20,000 years ago, more or less, there were 2 ice sheets. Western Canada. Canada was covered by ice, up to 4 kilometers thick almost. And there was 2 ice sheets. Laurentide ice sheet, which came from the north and the northeast. It was extremely large, extremely thick. There were the mountain glaciers, called the Cordilleran ice sheet. There was a landslide on Mount Edith Cavell in Jasper. That landslide put a certain type of rock onto a glacier that was flowing beneath Mount Edith Cavell. That glacier joined the Athabasca Glacier and flowed out to the east and northeast, where that glacier bumped into the Laurentide ice sheet. This valley glacier, with all of this debris, was deflected southwards, and it left blocks all along and in front of the Rocky Mountain foothills, including down to where we see the Okotoks erratic. So what would that look like? There's Mount Edith Cavell, lower left. And there was a glacier here at the time, and these rocks, there's about 1 kilometer of thick, highly cemented quartz called a quartzite. And it would have avalanched down onto the glacier, like I said, flowed out in this direction, out like this. What would that have looked like? Well, here's an example from the Alaska Range, 2002 in Alaska. Here's a giant landslide that's come out onto the glacier. Here's another one. Probably millions, hundreds of thousands of tons of rocks out onto the ice. And then that ice would flow down like it did here, and eventually we get deposition of something like the Okotoks erratic. So that's one interpretation. Another interpretation is if it deals with and looks at First Nations history. The Blackfoot word for Okotok, it means rock, which is very appropriate. One of the interpretations, or one of the creation stories, and this was related by Blair Firstrider, a Blackfoot elder. And this is an abbreviated version. He says that when Nappy, who was creating the earth, upset Okotok, it's to do, it was a hot day. Nappy had his blanket. He didn't want his blanket. He gave his blanket to Okotok. Later it became cold, and Nappy took his blanket back. Okotok became upset and started to chase Nappy. So Nappy was worried. He asked different animals to help him. He asked the bats to help to stop Okotok from chasing after him. The Okotok said the bats said they would help him, and the bats started crashing into Okotok. They broke off pieces of the rock that you see there. As a result, bats have flat noses on their flat faces these days. The saga continued. Eventually, Nappy asked the Nighthawks to help him, and that Nighthawks agreed, and they blew gas. You can translate what that means. They blew gas onto Okotok, and they broke it up for it to be the way it is there. And it was the Nighthawks who had helped and saved Nappy. So that's another interpretation of how Okotoks erratic came to be. Let's go east of Red Deer and continue the drama. Neutral Hills, disruption in the prairies. You can see these ridges, giant ridges in the middle of the prairies near Consort, north of Consort. And the Neutral Hills, they extend 70 kilometers across the prairies. They're up to 120 meters high. They're so prominent that Captain John Palliser, in the mid-1800s saw them and put them on his map. Why are they there? Glaciation again. We had ice advancing from north to south, lobes of glacier ice, and they were pushing the underlying bedrock below it. They incorporated large blocks of ice as well in these ice thrust masses, which is what these are. And then the ice melted, disappeared. This ice melted and disappeared. And as a result, we have these lakes in front as well. These are called Kettle Lakes. This is a nice little provincial park worth staying at. Again, there's another story on the origin of the Neutral Hills. This one's not attributed. We don't know where the story came from. The Crow and the Blackfoot used to live in this area. There's lots of buffalo, there were berries, there was lots of winter protection with the hills, lots of firewood. But the Crow and Blackfoot people were constantly fighting one another. Nappy, or the Great Spirit, became upset one day. In the evening or at night, he put his finger down, touched the earth, and lifted the earth up to create these ridges. In the morning, the two warring tribes woke up, saw the ridge of hills between them. They walked to a gap in the rocks. They met and they made peace. And therein comes the name, Neutral Hills. Let's go to Wally's Beach in southern Alberta, northeast of Waterton Lakes National Park, near Cardston and McGrath. There's a reservoir, and it's called Wally's Beach. And we're continuing the story about drama. This is a hike within a late Pleistocene landscape. It's a pretty bleak place. To see what I'm going to show you here, you have to go in late winter, early spring, when the reservoir is low. If you go there right now, the reservoir water levels will be up as high as the bottom of the screen. What you see there at low water are mammoth tracks. These are giant mammoth tracks. Mammoth tracks here. Different sediment, so they look different. There were mammoth that lived here. There's a close-up, probably 40 to 50 centimeters across. 500 footprints have been found and identified there from the mammoth. There are also camel and horse footprints. The interesting thing is that these date back to about 13,300 years ago. And the archaeologists have found remains of butchered horses and camels, and they've also found stone tools that had protein on them, showing that the tools were being used to butcher horses or muskox, or perhaps the camels. They weren't sure. They called them bovids. There's a picture of some of the bones and some of the artifacts. It was a bleak place. The glaciers had just left. The Rocky Mountains in the distance, there were still large valley glaciers. So the wind would have been blowing all the time. The giant Laurentide ice sheet that covered most of the prairies was several hundred kilometers to the north, but cold winds would have blown off it. There would have been few trees, and it would have been what we call a steppe-like environment, much like Mongolia is today. And here's Lucy's rendition of Wally's Beach. She's captured it quite nicely. Drama, dinosaurs perish, meteor impacts, and never-ending floods. Let's go to Dry Island Buffalo Jump for that. Here's Dry Island Buffalo Jump. And at the time, what we're interested in are these carnivorous dinosaurs called Albertosaurus. And in the park at Dry Island Provincial Park, 26 species, or specimens, not species, individuals were found in one deposit called a bone bed. They ranged in age, the paleontologists estimate, from 2 to 24 years old. They likely hunted in packs. You just imagine a pack of these coming after you. Why are they there? They became concentrated in ancient river deposits. Here's an example of from South Africa, or from Africa these days. This is Tanzania. And here's wildebeest, herds of wildebeest trying to cross a river. These are herbivores. They're not the carnivores like Albertosaurus. They get into the river and they drown. And after they drowned, their carcasses just become concentrated like this. And you can see the buzzards picking through them, collecting, dining on the rotting meat. The carcasses eventually get picked up, retransported again during the next flood, and are deposited in old river deposits, preserved for us to find now. Also in the area, we have bird-like dinosaurs this one's called Ornithomimus, and it resembles to a degree an ostrich. It had feathers, probably for mating rituals. It did not fly. That too was found in the Dry Island Buffalo Jump area. Drama, 66.5 million years ago, a meteorite hit the Earth. That meteorite was about 20 kilometers across, and it created a crater about 200 kilometers across in the Yucatan Peninsula, just in the Caribbean. And when that took place, or where that took place, sorry, let's do that again. When that took place, it was a catastrophe around the Earth. That took place, that event happened and affected the sediments that are right here. 76% of all life on Earth died right where this yellow line is. The dinosaurs perished. Lots of plants and most of the plants perished. We have iridium found in layers nearby this particular outcrop. Iridium comes from outer space. We know that a layer of rocks right in here is the result of this meteor impact. And from a nearby cliff, there is that impact site, the impact right there. This is when the dinosaurs died, right where that color changes, right below the coal. And there is the Red Deer River Valley. Here's an artist's rendition. And when the meteorite hit, there were instantly giant fires swept across North America. It became dark from all the debris that got sent into the atmosphere and soot in the air from the giant fires. There was acid rain. And then particulate matter in the atmosphere initially cooled the earth, and then CO2 levels went through it, and we had global warming. And at that time, as I say, 76% of all the species of animals and plants died. It was an absolute cataclysm. Let's leave the drama. Let's look at our glaciers that have affected Alberta over the last 25,000 years, and older for the volcanoes. During the last glaciation, Alberta was covered by up to almost 4 kilometers of ice. There would have been almost 2.5 kilometers of ice above Red Deer about 20,000 years ago. If you drew a line from north to south and just look at the thickness of the ice gets thinner from north to south. The topography of Alberta, if you go to Lake Athabasca, up in through here, almost at sea level. But when you get to southern Alberta, the elevation of the prairies at the border are 1,000 meters, 1,300 meters. The ice was so thick that it could advance and climb up the topography. Around Red Deer, there was about 3 kilometers of ice. These maps details don't matter. Just would like you to remember that in the last 2.5 million years, 2.6 million years, Alberta was glaciated several times. Edmonton was glaciated twice, here and here. Red Deer was only glaciated once. Calgary was only glaciated once in the last 2.5 million years. The most important glaciation for us was the last one, which was about 20,000 years ago. It created so much of our landscape. It covered Western Canada, except for a few hills that poked up above the ice, called nunataks, the Cypress Hills, the Porcupine Hills, and then down into the States. The ice started to melt, started receding, melting back. We'll come to Edmonton very briefly. 12,800 years ago, just about gone. 10,000 years ago, the ice had left Alberta. Very briefly, look at Edmonton. Edmonton's built on the bottom of an ancient glacial lake. Right on the margins of the ice, there is the ice shown in yellow. It was when the ice was melting back, a giant lake formed. That's why Edmonton is so flat. It's formed on the old lake bottom. But we're going to leave Edmonton. We want to get you out in the country. Let's go to Elk Island National Park. And the way I describe that is a giant block of ice melts to give us this rolling topography, lots of wetlands. Wetlands that the beaver love. Low-lying hills, or none of them are really too high. Lots of lakes, lots of marshy areas. Beaver love it. The buffalo, the bison love it. So the story on Elk Island National Park during the last glaciation, this was a little highland, not 20, it was 60 meters higher than the surrounding area. It was still covered by ice, but when the ice started to melt, well, before the ice started to melt, ice used to flow around this highland, this subtle highland. There is Elk Island National Park right there. Then when the ice melted, if you draw a line showing the elevation, we call it a cross section, this highland was left high and dry. And there was thick mass of ice that may have been hundreds of meters thick. It essentially rotted and melted in place. And the debris within the ice would shift and shuffle and move around to give us eventually the topography that we see the wetland topography that we see in Elk Island National Park and just south into Cooking Lake. Gives us this topography. And geologists came up with a lot of names to describe that topography, and the names don't matter as much as they're descriptive. Prairie mounds, rimmed ridges, ice-walled lake plains, prairie donuts. You can picture what Elk Island looks like by just looking at those names. Let's go to Cold Lake. I'm just looking at the clock. Let's go to Cold Lake. Why is Cold Lake there? It's a deep lake. It's one of our largest lakes. It's 99 meters deep. It was covered by glacier ice. And it is there because when the glaciers were there, the glaciers bulldozed. They actually acted like bulldozers and pushed out the debris that is now, I'll call it, pushed out the debris, making a hole that is now the lake. And it left a series of large hills around the lake, some of them to the south and some of them to the east. If you go south to Muriel Lake was formed by bulldozed glacier ice. And this hill that you see here came from Cold Lake. It was bulldozed by the ice. Again, the glaciers are so important for creating our topography. Other lakes in Northeast Alberta that are formed like this: Primrose Lake, Saddle Lake, Wolf Lake, Sinking Lake. You may have visited some of those. I'm going to leave this. We're going to go to Dorothy, southern Alberta, along the Red Deer River Valley, east central Alberta, we'll call it. And in Dorothy, this is one of the churches at Dorothy. In the riverbanks is this layer of material, gray, really light gray. And it's the result of a volcanic eruption that took place about 74 million years ago. And there's up to 13 meters of this ash there. And it was deposited into a shallow sea. There was so much ash that the skies above central Alberta had to have gone black, even during the day. And it gives you that spectacular color that you see all along the river valley near Dorothy. Volcanoes long past. Let's go to the Buffalo Head Hills. And Buffalo, no, I'm going to leave this one. I'm going to leave this one. Sorry, no apologies there. We're going to go look at when banks fail. And what I talk about here is when banks fail. Two examples. We're going to look at the Peace River. And when you go to the Peace River, on the town of Peace River, you can see that the banks are forever failing, slumping down into the river. It's a very common theme in many of Alberta's rivers. And the reason for that is, that we're getting in, rivers are undercutting the banks. The banks are failing. Old 100 million year old Cretaceous rocks or glacial debris. These bank failures can be so big, sometimes they could possibly dam up the river for a while. Just go southeast of Red Deer, go to the Red Deer River, go to Dry Island Buffalo Jump, and you can see bank failure all along through there. The S's represent bank failure, represent slumps. The last one is when banks fail, when Crow's Nest Pass shook violently. Here's the Frank slide on Turtle Mountain. Everybody's heard about it. It's so impressive to see. April 29th, 1903, Canada's largest landslide. The railroad and the highway were blocked. Half the town of Frank was destroyed. At least 90 people died. It's there for geological reasons. Mountain building has bent the rocks, weakened the rocks. Rocks have been pushed by mountain building, creating thrust sheets. That weakened the rocks. And there's an underlying coal seam. And mining may have helped to weaken the rocks as well. And as a result, we had the giant Frank slide. As a result of folded rocks, thrusted rocks, several glaciations, which steepened the mountain and coal mining. And it created this devastation. So the Scenic Geology of Alberta is a story of unbridled power. It's a story of drama, as we've shown you. It's a story of glaciers and volcanoes long past. It's a story of when banks fail. Just a scenic shot on the way to Dinosaur Provincial Park. And at this time, I'd like to thank two groups that have helped to fund the publication of the book. Canadian Geological Foundation provided a grant, and the Alberta government provided a grant. And I'm very thankful to both agencies for that. If you'd like to get the book, the first place that you should go is go to your local library. Go to the Red Deer Public Library. It was in Kerry Woods Nature Center, and Chapters Indigo carries it. So the book is available locally in Red Deer. Thank you very much for your time.
Well, thank you, Dale. I think you gave us lots of inspiration to get out hiking, that's for sure. And I, of course, have a few questions as a result of all that you showed us. So one of the last things you showed was Cold Lake, which is, I think, the second deepest lake in the province. So is it, you show that it was bulldozed out from two directions. Is that why it's deeper?
No, that's in part because first one bulldozing from one direction. When bulldozing, all I mean is the front of the glacier pushed this material, and then the ice changed direction a little bit, and it came from a different direction and would have re-excavated or excavated even more material. But that's a great question.
Well, it's just interesting that you know, which spots ended up getting excavated sort of is curious to me. Yeah.
And there's some springs at the bottom. There's some springs at the bottom of Cold Lake, and they probably would have been active when the glacier covered the area. And those springs, the aquifers, would have helped with hydrostatic pressure as well, probably to loosen some of the material so it could be bulldozed.
Okay, that's interesting. So many things have to come together for these things to happen.
I agree.
Can you just talk briefly about your very interesting backdrop?
Oh, the backdrop. That is at Rock Cooley. And so let me think about it. Rock Cooley, it's these marine rocks, these concretions, and they form just below the seafloor. And I talked a little bit about that. And what happens is all of the muds around them have been eroded in the last 10 to 12,000 years, leaving these bright orange calcite, and that's the cement or the rock material that's there, concretions. They turn red because there's a little bit of there's a little bit of iron in the calcite or with the calcite, and it rusts bright red. And then algae, an orange lichen grows on top of that. And that gives you that bright orange color in that moonscape there, Priscilla.
It's very, very, very effective. I'm glad that you touched on gold panning, because at the library here, that's a question we often get. People want to have some idea where they might go and, you know, try their luck. So that's great that you mentioned that. Thank you. And I'm able to refer people to your book on that question.
Good.
I also want to thank you for your illustrations. So I know it takes a long time to write a book, and you've got there's a lot of material and they're very dense and everything, but it must have taken you quite a while to do all these illustrations and collect the photos. And
yeah, it did. It was a lot of work doing that. And so the line drawings, yes, it did. And so I do them in some software. And then I worked with an illustrator, a graphics design person, and he took all of my work and he made it look very pretty. He added the pastel colors. I'm just a bright orange, bright blue, very basic colors, but he added the pastels, and that he makes it look so nice. Sergio.
Well, it goes well with the beautiful paintings as well. And you that was one of my questions, but you really touched on that incorporating the beauty of the province as well as the geology.
Exactly. Trying to integrate the two to help the reader just appreciate our landscape even more. So I think that's a good question there, Priscilla.
And the visualization, like that low-level bridge where you show the you know, how it must have been. Imagine them thinking having the time to put the train on the bridge to think that it would hold it.
And that was 1915. I was thinking about that today when I was re-looking at those images. It's so hard to imagine that they had the foresight to, yeah, let's put something there so we don't lose that bridge.
Yeah, and that the train company was willing to risk their train too.
Oh, yeah, exactly.
Yeah. I also really appreciate your explanation of the erratics and that the rocks came from Mount Edith Cavell and that circuitous route they took to reach us, because erratics are something we, everybody seems to know about, but not understand really where they came from.
Yeah, I think that one's an amazing story and just such, I'll call it such a spectacular story. And then you put the First Nations version of that interpretation for Okotoks erratic, and they're just as interesting, I think.
It is, yeah. So I'm not being out of school here or whatever, but you did say that you retired and you've been doing geology for quite a number of years. And I just wondered how much of the geological history has, that you maybe learned when you started out has changed to now, like, because we must keep finding new things and having new interpretations of why things are the way they are.
Yeah, there has been lots of change because we keep discovering new ideas. There's the concept of, we call it plate tectonics, where the plates on the earth and we get subduction, one goes under another. Well, 40 years ago, 50 years in the 60s, that was a brand new idea, and it was very, very controversial. But now it's just taken for granted. When the meteor impact crater was discovered, the one that killed the dinosaurs, that was a new idea from the 80s when they found the actual impact site in the Yucatan Peninsula, and that created all sorts of controversy. And so now it's pretty well accepted by most people. So yes, there's been a lot of new ideas, and they're ever evolving, but that's how science works. That's another awesome question. I like that.
So I wondered, what's next for you? Do you have something on the back burner?
Yeah, I do. I haven't started anything yet because it takes 3-4 years to write a book, but I've been thinking either doing a book on Saskatchewan like that, the same theme, or maybe a more detailed one on our cities, meaning Edmonton, Calgary, Lethbridge, Red Deer, Medicine Hat, the main cities. I mean, just thoughts and some things to think about. I talked a little bit about Edmonton and Calgary in this book, but there's so much more to talk about. And Red Deer is just another one. The Battle River is such a beautiful, beautiful river. Something could be written on the length of the Battle River. I love crossing it because it's so scenic. So those are some of my ideas.
Well, that's great. That's something for us all to look forward to.
Yeah, that's
really appreciate you taking time with us today. And as I said, I think everybody should get out hiking because we have the hiking challenge on right now. Thank you very much. So we'll see you all next time in October, and enjoy your September.
Hey,
thanks very much, Dale.
Thank you. Bye.
Bye.